All right, good morning. Welcome to Intermediate Algebra. We're going to talk about applications of rational functions here. Okay, so I'm going to go ahead and share my screen, see what's going on, and got some problems set up here. So this is kind of a walk through your homework if you're in my class. And just a warning, like, if you need help with it and this is helping, then please go ahead and do your homework with me. But I'm just going to warn you beforehand and tell you that I had a friend I saw a friend, she can do a cartwheel on a balance beam because she was a gymnast when she was little. And I've watched her do it many, many times. I cannot do it. So the moral of that story is you can watch me do it, but unless you're doing it on your own, you can't do it. Okay. So I just want you to, you can watch for the help and get started with it. But at a certain time, you're going to have to go through and actually practice this stuff yourself. Think about it, like if you just want to get the check mark for your homework, then this will work. But if you actually want to know what you're doing when it comes time for a quiz, then you're going to have to rehearse doing some of this like without a net, okay, without somebody showing you how to do it first. So if you're hitting show me an example, help walk me through this, ask my teacher, watching somebody else do it, like that's all great for learning it, but when you're rehearsing it and trying to prep for an assessment, you pretty much have to do this, fresh and without extra help because the quizzes don't have like ask my teacher or let me help me with this. Okay, so I just want to be really careful about how you use this and warn you that you know just having me do it doesn't really help as much. But to get started, sure. Okay. So what I would do the problem, turn the video on, watch me do the problem. Well, watch me start the problem, pause it, see how much you can do yourself, and then unpause it and see whether or not you've matched it. Feel free to play it twice speed or whatever to kind of get through it. Okay. So enough talking. Let's just get to it. Okay. If 4/5 is added to the reciprocal of a number, so what we're going to say is 4/5 is added to the reciprocal of a number, then what we're going to end up with is 14/5. Okay. Now, there's a lot of different ways to do this. Um, what we've been doing in class is the goal for rational equations is to clear the fractions first and then work on what's left. Okay, and I've been doing that for all the other problems. So even though there are other ways to do this, what I'm going to do is go ahead and say, well, what if we multiplied everything by 5x? Because 5x would be our common denominator. Okay, so my first step here, identify common denominator, but we're really trying to clear the fraction. Okay, I'm sorry about I don't know what's the interaction is between my little writing tablet and the screen here. Okay, so 5x. So on the first term, the 5 cancels, and we get a 4x. Okay, 5 cancels with 4x. With the x, right, the x is going to cancel, so we just get plus 5. And on the end, we're going to end up with a 14, right, because the 5 cancels 14x. Okay, so we have 4x plus 5 equals 14. Let's go ahead and subtract 4x from both sides. So we get 5 is equal to 10x. Okay, and then we should be set to go. Okay, so we'll have x equals 5 tenths or 1/2. Okay, a lot of times my statistics classes, like, they'll get 5/10 and I'll just leave it there. Like, really? Can't tell me half? So you want to reduce. If it's in your 12 by 12 multiplication tables you learned in elementary school, you should reduce. If it's like, 361, 19 over 361, I'm not expecting you to know that 19 squared is 361 and this reduces. Okay, you don't have to do that. But if it's within your 12 by 12, like, you should reduce. Okay, or like a really easy one, like 10 times tables or something. Okay, so half Okay, and it'll tell you, like if you type in 5/2, watch 5/10, like it'll get mad at you. Like, really? Be careful, wait till you're in simplest form. Okay, so they get mad at you too. Okay, so moving on. All right, and I won't do all of them. That way, actually, this one's a little tedious. Okay, these types of problems, these are pretty common. Okay, I'm not partial to them because I still have trauma from elementary school here. But here we go with this. I really wish I could change this. Get rid of that. Draw. Okay, he traveled 90 miles while driving in a bad rainstorm. Okay, the motorist drives 20 miles an hour faster and they cover 135 miles in the same amount of time. Find the speed of the motorist during the rainstorm and in sunny weather. Okay, so in the rain. Okay, so the best way to do these is, excuse me, set up kind of a table for it. So really, these are all distance equals rate times time. Okay, so in the rain, they traveled 90 miles. Okay, and shows, okay, that's all we know right now. But they're going to have some kind of a rate. Okay, we're just going to call it R right now for R for rate. In the sunny weather, then they travel 20 miles an hour faster. So here we are just making up a little table here. Scenario 1, we're in the rain. Scenario 2, we're in the sun. 20 miles an hour faster and covers 135 miles in the same amount of time. So we don't know what the time is, but we are going to be able to say that it's the same time. Okay. So one of the things we're going to be able to do here, because we know a rational equation section. So what's going to happen is D equals RT. So T is equal to D over R. Right? And the rain and the sun, and the time in the sun and the time in the rain, they're the same thing. Okay. So what we're going to have is we're going to have a 90 over R, right? That's the time for the rain. That equals T for rain. But it happens to be equal to, right, the time in the sun. So we're going to say, okay, 135 over R plus 20. And that's how you're going to set these guys up. Oh, why are you doing this? Okay. So you could either cross multiply or continue with the same idea of just saying we're going to multiply by a common denominator. Okay, clearing the fractions. So what's going to happen with the left side is the r's are going to cancel. So we're going to get 90 times r plus 20. And then on the right side, the r plus 20s are going to cancel. So we're just going to get 135r. Okay, so we're going to have 90r plus 180 is equal to 135r. We're just going to get all the variables on one side. So minus 90r. So we're going to have 180 equals, and then what do we have here? We have 135 minus 90. So it looks like we're going to end up with 45. Yeah, that'll work. And then r is going to be 180 over, okay, 180 over 45, and whatever that happens to be. So cheat here and go ahead and say 180. No way. Really? R equals 4. Oh, this is worth the effort. Oh, it's not 180, it's 1800. Okay. That looks a little bit better for a problem. Okay. My 10's there. Okay, so 40 miles per hour in the in the rain, and it's going to be R plus 20. So this is rain. Okay. And in good weather, this person drives at 60 miles per hour. Okay. So there we go with that. And person drives 40 miles an hour, right? Very good. And 60 miles an hour in the rain. Okay, very good. All right, let's go ahead and do another one of those because I know that these are pretty. Let's see. Okay, so for this one, okay, Kathy can run 6 miles to the beach in the same amount of time. Dennis can ride his bike 12 miles to work. Kathy runs 3 miles an hour slower than Dennis, who rides the bike. Find their speeds. Okay, and again, there's the same amount of time as. Okay, so we're going to have a little chart here. I'm going to have Kathy. We're going to have Dennis. We have a D equals R times T. Okay, so Kathy is running 6 miles. Okay, Dennis rides 12 miles, right? And in this case, she runs 3 miles an hour slower. So we could say R minus 3 and then put the R here. So this is going to be the speed of the bike. Okay, and again, they don't say anything about time. They just say, well, it's about the same time. Okay, great. So again, right, since D equals RT, T is going to be D over R, right? So, and since they're the same thing, right, we're going to have Kathy, D over R is equal to what Dennis is doing. Okay, so we're going to equate that. So our step 2 here is equate the times, equate the D's over R's. So we're going to have 6 over R minus 3 is equal to 12 over R. Okay, and again, you can cross multiply. I'm just going to continue with this theme of multiplying through by a common denominator to clear the fractions, because that's what we did in the previous section. The R plus R minus 3's, there's cancel, so we have 6R is equal to 12. The R's cancel, and we have R minus 3. Okay, should really be putting a bigger number on the left-hand side. I won't do that. So 6R is equal to 12R minus 12 times 3, 36. Subtract 12R from both sides, and we get negative 6R equals negative 36. Okay, divided by negative 6, divided by negative 6. So we have R is equal to a positive 6 miles per hour. All right, and that was the bike speed, right? That was what we're doing with the bike. So this was Dennis on the bike. And Kathy is running 3 miles per hour, right? 6 minus 3, 3 miles per hour. Okay, it's like my speed of running. Okay, and that's what we're going to do. So she's running 3 miles per hour, yeah. And what is he doing? 6 miles per hour. Yeah, it looks like it takes both 2 hours to get to their destinations here. So Dennis is 12 on the bike. No, 6 on the bike. And we'll check. And Kathy is going to be 6. Oh, sorry. There we go. That's better. All right, and then yeah, that's pretty much how you set those up. That's how you do them. It's going to be the same kind of solution every time we're going to be doing it. It's the setup that's usually the problem. Okay. So let's see. So we'll do one more. Okay. So we have a bicyclist rides 24 miles against the wind and 24 miles with the wind. The average speed on the return trip is 5 miles per hour. How fast did the cyclist ride if the total trip was 4 hours? Okay. So we're going to go somewhere and then we're going to come back. Okay. And again, these are not like, standardized symbols. Okay. These are, you get to make up what you're doing your own way. Or if you had a high school teacher, you really liked it, and you said, "Oh, he really set this up great. How come you don't know that?" I'm like, "Well, I don't." But feel free to use their setup. That's okay. If you're a tutor and you say you should set it up this way, and then that works for you, please do that. Okay. So on the one, actually, I'll put this backwards. So the wind, right? So we know what's going on. Okay. So again, we have D equals RT, D equals R times T. So, right, it's 24 miles against the wind and returns 24 miles with the wind. Okay. Average speed for the return trip that would be going with the wind, okay, is 5 miles per hour faster. So whatever the rate is, it's going to be 5 miles per hour faster. So our R is the speed with the wind or against the wind. Okay. We could even put a minus W in here if we wanted to. So this would be the rate like he would like with his still wind. But I don't know if they asked for that or not. Yeah, they didn't. They just said fine. Okay. Okay, and the total trip, the total here, this was 4. So this is just going to be 4. Okay, so would it make a sense if I said that we added these together? Okay, so we'd have, and again, we're going to have D equals RT. How do we want to set this up? Probably want to do something like rate is equal to D over T. Okay. How about T equals D over R? Okay. So total trip time, right, is going to be the amount that we went into the wind, and then plus the amount that we went out of the wind, okay, with the wind. Okay. I just kind of try to weave myself a little story as I'm going. So when I'm looking back at this, I can say, oh yeah, that's what I did. So these aren't really like that important with labeling, because really what we're doing is just this. Okay, but when I go back to say, okay, this was 24, right, against the wind, this was R plus, and then we have 24 over R plus 5, right, is going to be equal to 4. Okay, so 24 over R plus 24 over R plus 5 is equal to our time, which is 4 hours. Okay, so we've got another equation here. We have a common denominator of R times R plus 5, right? That's our denominator. We're not going to worry about the 1. Okay, and all I'm going to do, I'm just going to clear the fraction. Okay, so this is going to be 24. This R cancels. So we have 24R plus 5 plus, and then this 24, and then the R plus 5s cancel. We just have R, right? It's this one. And this is equal to 4, and then this is R plus 5. Okay, so let's go ahead and sort this out. So we've got 24R plus, now 24 times 5, what is that, 120? Plus 24R, and that is equal to 4R squared, plus 20, right, 4 times 5, 20R. All right, so we're going to have some stuff to work with, right? This is like the factoring chapter. Okay, so let's go ahead and deal with this. We have 48R plus 120 equals 4R squared plus 20R. All I'm going to do is switch the sides. So we have 4R squared plus 20R is equal to 48R plus 120. Okay, so next thing we have to do is it's a quadratic. So really what we want is the right-hand side to be 0. Okay, if it's a linear thing, like there's only r's, there's no r squareds, it's okay to do it where you just have r stuff equals other stuff and solve. Okay? But if you have a quadratic, you really want the right hand side to be 0, because when we factor, we're going to be able to use zero factor principle. Later in the class, when we use quadratic formula, this is a requirement. Okay, so we're just going to subtract 48r, okay, and subtract 120. So we have 4r squared. Let's see, minus 28. I think that's going to be 28. 28. Yeah, that should work. 20 plus 28 would be 40. Okay, 48 minus 120 equals 0. And hey, if I didn't know any better, I'd say each of these terms, right, are divisible by 4. So what I'm going to do is I'm going to say 4 times r squared minus 7r, right? 4 times 7 is 28. Okay, and then minus 30. Okay, and that's equal to 0. Divide both sides by 4. So this is just 0 still. Remember, 0 over something other than 0 is 0. And if we undo the multiplication, we say 8 times that, right? 0 would be 0 times what we had under here. And we're okay with that, right? 0 is equal to 0 times something. We're fine. If you do it the other way, and we do a over 0, pick what you want it to equal. Most people say, how about 0? Well, if I multiply both sides by 0, if you're a math purist, please forgive me, okay? So I don't even want to write that. But these would cancel, right? Just undoing the division sign. We get a is equal to 0 times 0, which is 0. And that doesn't make it easy. Like 7 would not be 0. So 0, a over 0, not defined, okay? But 0 over something, we can do, okay? So we have 2 things, right, that add up to 30, or to multiply out to 30, but add up to 7. The difference is 7. So how about we do an r minus 10 and an r plus 3 equals 0. Okay, so that's going to be negative 10. R plus 3r, that's going to be minus 7. We add them together, we get negative 30. We're good. Okay, zero factor principle. So we're going to have r minus 10 equals 0, or r plus 3 equals 0. Say r is equal to 10, or r is equal to minus 3. We don't really want our speeds to be backwards, so we're just going to say that's not going to work out. Okay, and so you never get there. Okay, so r would be 10, and then that's against the wind, right? This is the wind going this way, and we have r is equal to 15 with the wind. Okay. Looked at our setup at the beginning here. Okay, so that's what we have. And we'll go back and we'll take a look. 10 miles an hour against the wind. Right, hooray. All right, so that's what we have for those kinds of problems. All right. And then these are fun. So let me go through and I'll walk you through what the reasoning is here. Okay, so we have Karen can wax the SUV in 3 hours. Claren, nice, can wax the same SUV in 2 hours. If they work together, how long will it take? Okay, so here's the issue. If you say, well, what if we just average them? Then they'll be done in 2.5 hours, right? 3 plus 2 over 2. If they're going to be done in 2.5 hours, Claren, we just tell Karen, why don't you go home? I'll just do this faster myself. So that is not the case. Okay, so what happens in 1 hour? Okay, Karen gets done 1/3 of the job, and Claren gets done half of the job, right? It takes 2 hours. After 1 hour, she's halfway done. So this is going to be, what is this going to be? This is going to be multiply top and bottom by 2. So this is going to be 2/6 plus multiply top and bottom by 3, 3/6, and we're going to be 5/6 of the way done. Okay, so about 80% of the way there. So it's going to be like a little bit more than an hour, but not all the way up to 2 hours, right? Because I only have a little bit to finish. So the way that this works, the way it gets set up is we're going to have t over 3, right? Because we put 1 hour in here. If we put 2 hours in here, right, it should be 2/3 of the way done. Plus t over 2, and we want how much of the SUV to be done is 1. Okay, 1 whole SUV, 100% of the job. All right. So all we're going to do here, again, we're just going to clear the fractions. 6, 2 times 3. So we're going to have 2t, 6 over 3 is 2. 6 over 2 is 3, okay, is equal to 6, right? So we have 5t equals 6, or t equals 6 over 5. So 1 1/5 if you want. Okay, I think a fifth of an hour is like, what, 12 minutes? So 1 hour, 12 minutes should be the answer that we get for this. So this is going to be 6 over 5. Which answer is a fraction of a mixed number. I wonder if they'll take 6/5. Oh, they did. Okay. So that's how you do that kind of a problem. Okay, is you just t over the amount of time it's going to take, t over the amount of time it's going to take is equal to 1 whole job. Now, I suppose we could say, well, I was, with 2 SUVs to deal with, it's going to take them the same time to do it. 3 SUVs, we can put a 3 here, and so forth. Okay, so that's how we're going to set these up. I wonder if we have any more. Gee, thanks, the same problem. Okay, try one. 5 and 8 hours. Okay, so Ted can change the advertisement on a billboard in 5 hours. We can change the advertisement on the billboard in 8 hours. How long will it take them if they work together? Okay. So what we're going to do is we're going to have a t over 5 plus t over 8 is equal to 1. Right? So multiply by 5 times 8 is 40. So we're going to have, let's even do it this way. Okay. So it's clear that the 5's cancel, so we end up with an 8t plus that cancels. We have a 5t is equal to 40. Okay, so this is going to be 13t equals 40. And then t will be 40/13, which I think is 3 hours and 1/13 of an hour. Okay. Now you don't have to do that. Watch this. Even if you have a smaller calculator, it still has an ABC button, has a ABC button like that. So you could type in, you could say 40/13, enter, and you say, well, this answer doesn't look like that. Like, no, but we can change back to a fraction. 40/13. Oh, they can't do that. I'm not seeing it on here. Oh, let's just be happy that sometimes the smaller calculator actually does more stuff sometimes. Okay, so there we have it. So 40/13, that's just fine. I take that. Yeah, I did take that. Okay, so that's applications of rational functions. I'm going to stop here because it's already been long. And, like I said, you could do your homework with me, or if you're stuck someplace, watch one of these and hopefully get unstuck. All right, so thanks for coming, and we'll see you in the next video. Goodbye.